रेकॉर्डचं केलं का चालू?
रेकॉर्ड चालू केला.
Good morning, everyone. Our project topic is timetable using parallel search optimization. Next. Introduction. As we know that the timetable generation is very important task in our day-to-day life. Many institutions made hundreds of timetables in each and every semester department-wise. Earlier, the timetabling was handmade, but it was really very time-consuming and complex. So, for reduce its complexity, we are going to develop a system which can develop the timetable automatically. This timetabling problem is very important problem for every university. Using parallel algorithm to solve this problem. Also, we are using CUDA framework for this parallel computing problem solving. Next. Objectives and scope. The system should be efficient to schedule the academics using parallel computation. The allocation of resources to the objects being placed means all the resources and lectures should be scheduled properly. The lectures should not get overlap, or the faculty or staff allocated to the particular lecture should not get the many lectures at a time. We are using GPGPU framework for developing this system. The GPU device is used for developing this software. We are going to generate the departmental timetable as using CUDA. We can use this system for generation of many timetables by master timetable. Next, I am handovering this to Shubham.
Yes. So the problem statement for our project is development of an efficient system to generate academic timetable using parallel search technique. Next. So here we are using 4 papers. In the first paper, the different tuples are generated in the form of chromosomes. The chromosomes are nothing but the set of subject, faculty, location, day, and time. As well, in the second paper, it is all about the constraint satisfaction problem. The constraint we are going to use in our project to generate a efficient timetable. And in the third timetable, the constraints which we are using the constraint which we are going to use is mentioned, and all these papers. In the first paper, we are using genetic algorithmic approach. In the second, we are using AC5 algorithmic approach. So next slide. Next. So in architectural diagram, so we are going to get input in the form of location, faculty, students, and subjects. These are different constraints which we are going to use to generate a timetable. So by using parallel BFS algorithm, we are going to design a master timetable by giving these inputs in the form of location, faculty, students, and subjects. We are going to generate a master timetable, which is consisting of different timetable. For example, laboratory timetable, faculty timetable, classroom timetable. So this timetable are going to use for every year, for second year, first year, and third year, etc. So now I will hand over to Anaka.
Okay. Each tuple consists of a set of faculty, location, periods, periods. F represents a set of faculties, L represents a set of locations, P represents a set of periods. Then next. Then our goal is to satisfy all the possible constraints. There are 3 constraints which needs to be satisfied. First one, no location has more than one course in one time period. The second constraint is no faculty has more than one course in one time. And the last constraint is that each batch of students cannot attend different lectures at the same time period. Next. Then the software requirements for this software are the operating system should be Windows 8 plus or it should be Linux. Then the language which we are using for developing this software is Numba. Then the hardware requirements are 2 GB RAM, 100 GB hard disk, and NVIDIA graphics card, or we can also use Google Colab, which has built-in access to GPU. Next. Then the input to the system is going to be provided in the form of files. Then for each year we are going to provide 4 different files. First one is the lecture file, where it consists of lectures which are to be scheduled along with the teachers which are assigned to teach that particular course, and the number of lectures which are to be conducted per week. Then second file consists of a list of practicals which are to be conducted for that particular year, along with the teachers assigned and the lectures to be conducted per week. Then the third file consists of a list of classrooms, and the fourth file consists of a list of laboratories. Next. Then first we are going to take the input from the user in the form of files. Then from the files we are going to generate various tuples for each year. Next. Then each tuple consists of, first one is the course or the practical. Then second tuple is classroom or lab. So, sorry, the first element of the tuple is course or practical, which is to be conducted. The second element is classroom or lab, and the third element is the faculty name. For each year, these tuples are going to be generated. The number of tuples which will be generated is equal to the number of lectures and practicals which are to be conducted in a week for that particular year. Then once the tuples are generated, then we are going to generate all the possible permutations of that tuples. Next. Then on this tuples, we are going to apply constraint checking algorithm. As I mentioned before that there are 3 constraints which needs to be checked. We are going to verify whether these permutations are satisfying these constraints. The permutations, the permutation which is not satisfying this constraint is removed from the solution list, and others are considered for timetable generation, and the permutations which satisfy all the constraints are going to be considered for timetable generation, that is the output. Next. Then result will be explained by Satej.
The result of the timetable scheduling using parallel search optimization looks like this. The conclusion: the intention of the system is to generate a timetable schedule automatically satisfied. The algorithm incorporates a number of techniques aimed to improve the efficiency of the search operation. By automating this process with the help of computer assistant, timetable generator can save a lot of precious time of administrators who are involved in creating and managing various timetables of the institute. Such an algorithm can be also used for generating train scheduling and aeroplane scheduling. We have successfully designed a timetable using parallel search optimization. Thank you.